All right, so today's topic is density. So what is density? Density is the mass per unit volume of a substance. Now, as we're going to find, per means divided by. Now, the simpler terminology I like to use about density is the amount of matter that is packed into a certain amount of space. So, for example, Mr. Black has a green foam ball. Now, it's matter. It's made of atoms. Okay.
It exists. Wait. Yep.
Yep, it exists. It's matter. So he's going to put it into this beaker. Okay. So it's not very tightly packed, though. Now, Mr. Black is going to put it into this smaller beaker. He's going to make the matter pack into that beaker more tightly. Now those molecules of that ball are more tightly together. So do you think that's more or less dense?
Well, let me see. The volume got smaller, but it's the same amount of stuff that you packed in there. So if you pack the same amount of stuff in a smaller volume, it's got to be more dense.
You are correct. So it's more dense.
I retire.
Now, I put a picture of population density on there because you might have heard this term in a geography class or a social studies class. Other areas of stuff like to use the term density as well, but we're going to be focusing on the purely scientific application of it.
So yeah, in science we tend to like to quantify everything. So we like to have numbers with stuff, and calculating is great because math, whether you like it or not, is actually the basis for everything. So for us, for density, we have this really super easy formula called the density formula. And it's just simply density is equal to mass divided by volume. Might be a good idea to write that down in words, not just in the letters. Might help you remember.
Put the words
Might
down.
help you remember.
it.
So we're actually going to run through a few things we've done already because it all builds into this whole concept of density.
All right, so the first thing we got to talk about is mass. If density is equal to mass divided by volume, you've got to know what we're talking about. Mass is just a quantitative measurement of like an object's resistance to acceleration. The definition I like is just basically saying it's the amount of matter that an object contains, how many molecules, how much stuff it's made up of. So mass is how much stuff it has, how much matter.
So the more matter you have, the more massive, or
The
less
more matter, the more mass. They go one and one. It's that direct relationship,
Nice.
guys. The more matter, the more mass.
easy to remember.
The base measurement of mass is grams. It's one of our base units up there. We're going to see right in the middle of our little metric bar that we have up there at the top. We're going to be using grams in this class most of the time, and that's going to be our old buddy, the two balances, either electronic balance or we're going to have the triple beam balance.
All right.
And if you notice, there's also in that formula this thing called volume, and volume is just simply the amount of space an object occupies. So we typically measure that for two different ways. If you're talking about a solid, we're going to measure it in units cubed, like cubic centimeters or cubic meters. That's important. Remember, cubic centimeters for a solid. That's going to come back later.
Think of it like this, 3D, right? So you have the 3 above the number.
Because you're doing
third dimension.
length times
I live
length
there.
times width times height or something like
That was good.
that.
You almost got it. All right.
Anyways, I'm special. All right. So liquids, on the other hand, we're going to measure a volume in milliliters or liters. So volume is for liquid, milliliters, solid, cubic centimeters.
All right.
And what I was trying to show, and I failed horribly at, was finding the regular shaped object is using length times width times height. So you have length, height, and then width. There you go. That gives you your cubic centimeters, because centimeter times centimeter times centimeter, cubic centimeters.
Multiply them together.
Now, go ahead.
I was going to say, and if you have an irregular shaped object, say like Mr. Harkins here, and I need to get his volume, can't use a ruler.
Too
Too many
irregular.
weird shapes. So what we do instead is we use that water displacement method we know about and we've been talking about, and just drop it in, watch the volume go up, subtract the two, the difference is the volume of the object.
Yep.
And one really important key thing,
Super important.
1 cubic centimeter is equal to how many milliliters, guys?
One.
One.
Zero.
Exactly.
One and one again, they're a standard. They're exactly the same, except one is used for solids, a cubic centimeter, and
One's used for liquids.
yeah.
And we bring this up because in the water displacement method, you generally get a measurement of milliliters for the volume of a solid. But do we measure solids in milliliters?
Nope, you use
Nope.
cubic centimeters.
Cubic
So what you
centimeters.
want to do is erase that ml, put in cm cubed, that's it. If it comes up
Done.
42 mLs, it's 42 cm cubed.
By the way, this is not a coincidence that 1 centimeter cube is a milliliter. This is actually something that was standardized by scientists a long time ago.
Yep.
That's how it came about.
So anyway, if you were to find the volume of a liquid, you would use a graduated cylinder. Search for milliliters. We've done this before. Yeah, there's our graduated cylinder. Now, you'll notice that on your note sheet will have filled out like the equipment needed for each of these measurements. Now, the thing is, density, there is no piece of lab equipment that really measures the density.
Nope.
You need to measure the mass, and you need to measure the volume, which is why we just went over it. And then you need to use this formula, density equals mass divided by volume.
Yep.
To
Gotta
do a
figure it
little
out
bit
for
of math.
yourself. A little bit of math, tiny bit. I can do it, so you can do it. For this one, density of a solid, again, be sure when we do this, same formula, doesn't matter what, we're finding density, so it's density equals mass divided by volume. But make sure you're using grams per cubic centimeter. Again, that's cm cubed because it's a solid.
Yep. And then for liquid, still grams at the top. Mass is always grams no matter what. And then since it's liquid, the volume is going to be in milliliters.
Very good. So if you were to compare, if you were to take one particular substance and you were to compare its liquid, its solid, and its gas state, which you guys have done before, you'll notice that solids are always the most dense. Liquids are usually a density in between gases and solids, and then gases are usually have the least density. Now, the only catch here is the only thing that really, well, there's more than one thing that violates this rule, but
The main
one of the things that violates this rule happens to be like the most abundant substance on the planet, which is water.
Yep.
Okay? Water, if it freezes, you'll notice an ice cube floats at the top. It has to do with the way that the molecules arrange themselves as it turns to a solid.
Right.
We won't get into that because that's pretty complicated stuff. But pretty much everything else in the world, like let's say you take iron, okay, and you were to put iron that is solid into molten liquid iron, drop it in, it would sink to the bottom, okay, because it's more dense. Because generally solids are more dense than the liquid
Yep.
state of any sort of object.
That's also why gas bubbles go up.
Mhm.
Yeah.
Yeah, exactly.
Less dense.
Or
So
like,
let's summarize this. Like, so what are we getting at with all that? What does this mean?
Well, the big thing is that objects that are more dense than the liquid that they're placed into are going to sink.
I
So
can
think like a
follow that.
rock.
mhm.
Like if I took a rock, oh look, a rock.
Yes, that I happen to carry with me everywhere. Don't ask
And
why.
when we stuck that into water, it would sink. It wouldn't float. It would
Yeah.
sink. Objects, on the other hand, that are less dense than the liquid you put them into, say like a block of wood that Mr. Carnson has, will float instead.
Yep.
So objects that are more dense than the liquid or gas that they're in will sink. Objects that are less dense than liquid or gas that they're in will float.
Is that
Yeah.
why we don't float in this room? Because the room's full of gas and we're more dense?
Pretty much that and gravity, that little
Got
thing
it.
called gravity.
Oh, yeah, there's always that.
But the density helps too.
Yep. So, one final thought to leave you with is this one little thing you got to memorize.
Right.
You
Because
have
we're
to-
going to be doing a lot of measurements with liquid water. Now, liquid water has a density of, well, first, before I even say what the number is, what units do we use for liquid density?
It's a
Think to yourself.
Liquid, it's ml. Liquid
Is it just
ml,
milliliters?
Milliliters.
It's density, so
density,
it's
so it's
something
got
per
grams.
milliliter.
Grams per milliliter.
Grams per
Grams per
ml
milliliter.
because it's m mass over volume, so it's grams over ml.
Right? And it's
Got it.
liquid.
All right, and there's a really easy number to memorize here.
I'll never
It
do
is
this.
1.
I can't remember that.
Gram
That's too hard.
per milliliter.
1, that's hard.
Just
All
one.
right.
I'll try.
If you can remember one thing, liquid density of water is 1.
So
gram per
water's
milliliter.
density
Okay.
is 1 gram per ml. I'm gonna have to write that on my arm.
And once again, this one isn't a coincidence. This is another thing that was standardized by scientists. In fact, a gram is officially the mass, like people standardize a gram as the mass of 1 milliliter of water. All right? So, Mr. Harkins, you got that written on
I
your
got
arm?
it.
All right.
Use it on the test.
Cool. That'll be it for today. Have a good day.